Okay, so again, hello to everyone who joined a little bit later. Uh, Today I will be talking about Colette. And Colette is a low-code tool to create, manage, and profile data processing pipelines. And when I mention data processing pipelines, I mean, like in most cases, I mean these four types of jobs. So it's about ETL task when you need to extract data, transform, load it into another system. When you need to do some batch processing, or you need to scrape some web pages or get some data from APIs, and for analytics reporting. So whenever you have these jobs, Colette can provide like set of utilities that you can use to get your job done faster and simpler. So I already presented myself a little bit, but to sum up, I'm Sergei. I'm working as a software developer for like past 12 years, and 7 of them is doing Clojure. I'm living in sunny Spain. I very like it in Valencia. So it's pretty much all about me. And yeah, before I begin exploring the Collet, I want to say big thanks to Ben Bramley. He encouraged me and supported and gave tons of feedback on the Collet. So he helped me a lot. So thank you. And later today we will dive deep into some Collet internals and some underlying technology, but to give you hands-on feel about the tool, I would like to show you the demo of how it works and what it does before we will proceed. So I assume you can see my screen now, and what I will do now, I will start the command line tool, called Colette. It's written in Babashka, so it has .bb extension. And I'm just passing 2 parameters here. Is the path to the file you see on this. This file is just the Eden, just usual Eden file. And we have config Eden file as a configuration parameter. So when I will start this command, we will see the prompt where we can do some actions. Even without starting a REPL, you can try out Colette and perform some task. So right now, this file looks very simple, but yeah, this is just an example how you can structure your pipeline. There is quite a little of required keys, and everything else is optional. So you have to provide name for your pipeline, and you have to provide the set of tasks to execute during your pipeline run. And every task is just map with name, 2 distinct different tasks between each other, and the set of actions. So it's kind of nested structure to describe your workflow. I will comment out this example and will show the different one, which have some actions inside. So this is the same structure, the same map, where we have name, where we have tasks, and there's optional key depths where we can describe our runtime dependencies we will need to get for our pipeline. And we have only one task which called fetch GitHub repos. By the way, in this demo, we will build the simple pipeline that fetches data from GitHub REST API, and we will calculate some statistics on top of the data. So this action here has type HTTP request, and it goes to GitHub API with some parameters and returns body as a result. So I will save this file, and all changes to your file, they will be picked up by Colette CI tool, and we can execute task. When we run the execute task command, Colette suggests us to pick the task we want to execute. If we would have more tasks than one, we would see here more names, and we can pick the task we want. But for now, just one, so we will execute this task. Yeah, I forgot to do one thing. So actually, task is run successfully, and we see some results from GitHub API. But receiving results in that way, not very useful. So we have a special option here, like open portal view. And Colette integrates with portal. So you can open the portal view, and if we will execute our task again, we wouldn't see these data here as we saw in the first run, but we will get the result of the task in this more comfortable view in the portal. So we can see the result. This is just a vector of some maps, which represents GitHub pull request, not pull request, repository. Yeah, here we go into the repos of Clojure organization, and we're getting all repositories from Clojure. And here we have this response. Also, here in portal, we can see what was the type of the task. It was HTTP request, and we can see all incoming parameters to our task. And for example, here we can see OAuth token, right? But here we not hard coding our tokens and sensitive data. We can just refer to the data from config. And config, if you remember, when we run this task, we provided the second parameter for this config Eden. I will show you it quickly. It's just the Eden file where you can refer to environment variables with this special reader tag env. So in your environment, you can have different variables for different environments, but you don't have to change it in the actual pipeline configuration. So, but it will go to the task when it needed. Okay, so let's make it more useful a little bit. Right now, just get the list of pull requests. Let's create another task. So this is the copy of the first task we already saw. And this is the new task that goes to the specific repository, yeah, like here, table close. And this task gets the pull requests, the list of the pull requests from the same API using the same parameters. And so I will save this file. And when I ask Colette to run task, it suggests me like two tasks. I will pick up the second one, and we can see it's here. It gets some PRs from GitHub. We can see it and introspect like what's returned, what data required for our pipeline. So the next step would be to combine all these two tasks together, because this one just gets the list of repositories. This task gets just one random repository and pull requests from it. What you would actually do in the real world tasks, you need to iterate. You get like the first batch of data, and you need to iterate on it and get some details about every item you get on the previous step. So in Collet, you have special key called input, and you can specify dependencies between tasks. So all data from the first one will go to the second one, and you can refer to this name for data through this name. So here, what we are doing, we running this task, GitHub PRs, in parallel, limiting the number of threads to 4 threads. And we saying that run this task for each item in that list. So in parallel, like 4 requests will be done in every point in time while it exceeds all these items in the list. And every item, you can refer it with some special key with $sign in front of the name. And you can refer to any data inside that map that we saw. So PRs comes as the maps with all these keys, and we need just name. There was somewhere name key. And we can substitute that repo name to the next call, HTTP call, and use the name at the part of the URL. So this vector basically, like you would call the format, the standard Clojure function format with some placeholders and some arguments that have to be substituted. So, okay, no more words. Let's run this task again. So we already executed this first task. And what Colette does under the hood, it keeps the state of the previous runs. Yeah, so we don't have to run the first task again during our session here in the terminal. We can just run the second task again, and it will use data that was already stored in the internal state. Okay, let's run it, and we'll see what happens. So you can see now much more requests done for different repositories from the organization. For example, this one, this request goes to tutorials, and this one, Docker Hub, and so on. So now we have the first task that gets the list of the repositories, and now we run the second task for each repository and get some PRs for each repository. Okay, we can go further with it. We'll comment out this part. And let's make some use of that data. Yeah, we downloaded a bunch of details about pull requests. We can calculate some useful metrics. For example, here we will calculate the number of PRs by every member in the organization, and we will split it for on per month basis. So this will be our third task. Yeah, the first one and the second we already discussed it. They get the list of pull requests, and this one has type slicer, and slicer is built-in action in Colette that can slice through your collections. You can select some columns, some fields, you can aggregate them, and this is what we will do now. So here in the apply, we can provide the set of transformations for the collection of data we're interested in. And we can map over the collection and prepare like this value, year months. So year months will be our value to split the collection for temporal parameter, and then we will apply the fold operation that will use 2 parameters, user and year months. So it's kind of like data frame here. So, and you can specify like, give me like groups of records that have in common these two fields. And columns means like which columns we want to get from the collection. Okay, I think that's pretty much it. Let's try and see what it will do for us. So I'm running the task, and it should. I didn't pray to the demo gods. Yeah, that was some. Let's try again. Maybe I did some mistake. So we getting the inputs and we're feeding it to our action, and this set of transformations should work fine. All dependencies should be here. Let's try again. Okay, some unexpected error just happened. It was working just a few hours ago. Okay, let's close that window and open portal again. And we'll execute tasks again. So we need repos. Okay, it's done. We need PRs. It's done. And let's try again. No. I think, yeah, I'm just printing the stack trace. Okay, not every demo has happy end, unfortunately. So I wouldn't spend more time on it, and I will show you the results. I'll already run this task, which calculates number of PRs by member per month, and I have the plot with the results. For example, this is the number of PRs. I executed it for different repo, so names are different from the real ones, but the pipeline was the same. So you can calculate the number of total PRs per user, and this is the view by user per month. So you can see different users colored with different colors, and the bar size corresponds to the number of PRs closed by user. So you can try execute this pipeline yourself. This hidden file with this pipeline is on GitHub. So the final version of it, it's a little bit complex than I showed in the demo, because it deals with pagination, because you could have more than 100 PRs or repositories that allow it by GitHub. You can get just 100 items per request. So this pipeline deals with pagination, and here's the reporting section, which produces these reports, for example, for total PRs, for merge ratio by member, for monthly PRs, and for average time to merge for PRs, also split by members. So yeah, that's it. That's how you would usually use Colette. So you have your hidden file, which describes what should be done. You can put some custom functions. You can use built-in operations, and you have command line tool, so you don't have to even spin up your repo, and you have like this viewer. You can track what's going on under the hood. Okay, now let's back to our deep dive into Collet features. Well, yeah, before we'll get to internals, some may say, like, may ask, like, why to build yet another pipeline engine? Yeah, we have tools like Spark and similar things. But for me, when I've been working with on projects where we had to deal with large volumes of data, there is always trade-off between performance and flexibility, right, and resource consumption that you have to deal with. And I tried to build like data pipelines just with plain functions with existing tools into Java and Clojure ecosystem. But I think power of data frames that you can like abstract the way you're dealing with data as a data frame and like handle the heavy lifting parts on the data frame. It's like the superior thing. And for a long time, Clojure ecosystem like didn't have the good data frame abstraction, but then Tech ML dataset pops up, and Colette actually like using Tech ML dataset quite heavily, so we can easily map these built-in functions when you just say what you want, and TechML will take care of the rest. So yeah, that's what was like the first reason to use this powerful abstraction under the hood. Another reason, like why to build such thing, is to handle the heavy lifting. As I said, I worked on different projects, and every time you have to deal with like pretty big amount of boilerplate to set up the same tools every time. Talking here about logging, like metrics collection, resources management stuff. That all these things, they kind of important, yeah, for production systems, but they are like, let's be honest, they are boring to deal with, yeah, and you have to carry on like from one project to another project the same things. So Colette is kind of a thing that have batteries included. It can collect logs, metrics. It can deal with like these heavy liftings. So you can focus on the things what matter. And yeah, another point is to cover end-to-end stack. For example, like when I look into the existing development, mostly like around Python, there is a lot of great tools. For example, Airbyte, right? This is the tool to extract data from different sources and then push them forward to other systems. But this is a great tool, but it can just like extract and load data. And then you need to something like dbt to process your data, to do some modeling, to extract some data that really matters and filter out the rest. And then you need something like Duckster to orchestrate, to schedule it in the right way. And then you need to some different visualization tool. And you will like end up with 5 different stacks, different languages or DSLs, and you have to manage all of them. And yeah, it might be too ambitious right now to say that Collect can cover the whole stack, but eventually, almost sure it will. So right now you can extract data, you can transform it, you can load it, and yeah, I saw I showed you some visualization. It's not ready for public, but yeah, it will be using like Vega, a library to, so you can do some visualization for your reports in future with Collet. Yeah, and last but not least is simplicity. We, as a Clojure devs, looking for simplicity, and big inspiration for me in that space is DuckDB. I put their logo here because it was pretty amazing for me in the era of like this heavy enterprisey data warehouses like Redshift and Snowflake. It just appears and you can do with DuckDB almost everything just on your laptop. It's very simple to set up. There's no clusters on top of Kubernetes that will handle your data volumes. It just works. So I would like to like envision Colette as a DuckDB, but this is a simple tool that you can just run on your laptop or on a simple EC2 machine, and it will just handle all the data for you. So yeah, this is the reasons like why and where Colette can be useful for you. So okay, we saw Colette in action. We briefly spoke like what it is, and now this is the good time to see how it works under the hood. So right now, Colette is the 4 separate packages. They kind of dependent on each other, but you can use any of them separately, including upstream dependencies. For example, Colette core package, this is the main abstraction of pipelines, about tasks, about actions. The core package is responsible for managing dependencies and responsible for the correct execution of your tasks. And Colette Actions is a separate actions library that designed to get data from third-party sources like databases, APIs. It could be just REST APIs. It can be all data, specific API format, or it could be S3 storage for uploading and downloading files. So yeah, this is kind of third-party integration mostly. And we have app. This is the container you can run in production. When I say container, I mean Docker container. It packaged with different tools like metrics collection, logs. There are some like profilers. So this is the thing you would normally use on production. And there is a CLI tool that you would normally use during the development process. So the CLI, you can build your pipelines and then you can run it with app package. And optionally, you can refer to the actions package to bring some integrations. Yeah, this I already touched a little bit how to execute and start to work with Colette. So you just need 2 files. You need one hidden file with actual pipeline configuration, and you need some config file that will handle sensitive information like tokens, passwords, etc. This doesn't have to be like the static file on your local file system. So instead of configuration and specification hidden file, you can provide the link for S3. You can just put raw Clojure map with values instead of this file, so everything will work in the same way. And pipeline, yeah, configuration, as I showed, this is the simple map. It's an immutable map. It will be compiled on the startup. All environment values will be substituted in the right place, and it will be never changed. But you can reference any values from configuration in every task, in every action where it required for your pipeline. And pipeline specification even has two additional tags that you can use in your configuration. I will briefly show you what they mean. For example, this is my pipeline configuration, and I have a separate file, name it GitHub request Eden, and this file is just a template. It looks like this. So it describes the parameters required to perform request to GitHub API. And in the main file, I'm just referring it with this special include tag, and I can override any values on any level inside this file. So it will search for this file, it will bring the map, define it here, and it will do deep merge with parameters provided here. So this is the special one special tag for pipeline specification. So you can, if you have like the big pipeline with repetitive tasks or actions, you can just split it into files and refer to them with this include tag. And yeah, we have RGX special tag, because you might be aware that in Eden you cannot specify the regex. They will be, actually Eden parser will throw an error because it cannot handle regexes. But sometimes you need this, and this is the special thing that you can use to write and read regex in Eden. In general, this is how the pipeline will look. In common, you have the pipeline with the set of tasks, and every task can have set of actions. A little bit of like responsibility of each of these objects, like pipeline itself. This is the top level thing in the Eden file, but also pipeline. This is the object in memory that when you run your pipeline, and this object keeps like internal state. At every point in time, pipeline object knows like what is running now, like what the state of each task, what was like returned from every task. So this is like stateful thing that you can ask questions like what happening, which actions is running, what the state, if it's still running or it's done, or what was the error during the pipeline execution. Actions and tasks, they differ in that way that actions, you can think of them as just plain functions. So every action can do one thing, one small thing, and you can compose different actions under the task. And task is a logical piece of work. For example, if you need to get all pull requests from GitHub, you need to iterate through the different pages. You need to implement pagination, but like the logical task, just get the list of all PRs from that repo. Actions task could contain multiple actions to perform just this logical thing. Sorry. And there is a number of built-in actions in Colette that you can use. For example, like counter, it will just increment the counter on every iteration. So you can use it to implement pagination if you need to just increment page and go to another page. and so on. And we have mapper action that can take a collection and iterate over every item in the collection, and they do some work for every item in the collection. And we have a fold that will collect items into single sequence. So both of these actions, mapper and fold, can actually combine it under the next action enrich. So you can feed collection to enrich action. It will iterate, perform actions, and will enrich the data, and then it will use fold under the hood to collect all items back into single sequence. So useful for data transformation, or when you need to get data about the same entities from different sources. So you can use these actions like mapper, fold, and enrich. And we have special action switch. I can probably show you quickly here how it works. Yeah, so here we have switch action, and you can branch your logic between multiple branches to perform different tasks based on the conditions of the state of your pipeline. For example, here, checking if we have next link, so GitHub API returns special header with the next link to the next page. And so we can check if we have the link returned from previous request, we can just follow the next link. Yeah, if we don't have that link, we can do like another action. And we have special default condition, which will work if none of the previous match it. So we will go to the default branch and we'll execute just this action. And yeah, I think the most interesting action we have built in Colette is a slicer. So slicer can group your collections, can split them up, can join different collections together based on some criteria. And yeah, you can do whatever you want with collections, because this slicer action uses this TechML dataset abstraction. So when you working with slicer action, you're actually working with data frames or data sets in the terminology of TechML library. And we have stats action to, if you need to calculate mean, sum, or variance on the collections based on columns. So you don't have to reduce, you can just put stats with metrics you're interested in, it will give you some responses. And of course, like there is a few more options to make like Colette flexible. It's hard to predict what actions will be required for for all users. So with Colette, you can provide your custom actions. You just need to provide type custom and write your own implementation of the function. I think I already showed briefly to you what does it mean. Yeah, but actually it works something like this. So you can define a function. It looks like normal Clojure function, but inside the Colette, we are using small Clojure interpreter, the thing that powers Babashka and other libraries. So all your custom actions will be executed in a separate environment, which has limited access to the global state, global variables and functions. So it's more safe than just evaluate random functions at your runtime. So yeah, we're kind of limiting the context of the functions to be more safe. And you can refer to any Clojure built-in function if you will use like clg/ and then the name of the core function. So you can use action that refers to the Clojure core function. Okay, let's move forward. We spoke about actions and pipeline, and tasks is like, as I said already, this is the logical unit of work, and tasks have these special key inputs, and using these inputs, we actually building like a direct acyclic graph of the between tasks. So we know which task depends on what the runtime, and we can execute them in the right order. Also, tasks responsible for retry and error handling logic. You can specify in the task configuration like how much times it should retry with which intervals, and how to treat the errors if they occur. For example, you can skip errors, you can stop pipeline, and pipeline itself can be stopped or resumed in the runtime. The most like used and important part of the tasks is that you can define the execution model for them. So you can use tasks with iteration. So you can provide special key iteration, and you can define how much times it should iterate, maybe on some collection for some items. So tasks can be executed multiple times. And as we saw in the demo, you can define the parallel keyword that will run your task in parallel. Right now, you can pick one of these two, or iteration or parallel. You cannot mix them both, but maybe in the future we will add some third mode for task that you can run task in parallel, but inside every parallel task you will have the iteration if you need. Yeah, but for now we just need to pick one. Yeah, and as I said, pipeline responsibility is to keep state, to know what's going on with tasks, like how much tasks run in parallel. You can limit on the pipeline level, the max parallelism factor, and you can start, resume, pause pipeline if you need to. So this is the pipeline aim and responsibility. Okay, I think we still have some time, because I think the next section is one of the interesting ones, and here I want to discuss how state handled inside the Colette. Because we are talking about big data, like data processing jobs, so you have to deal with large amounts of data. And state in the Colette is kind of a mutable thing that evolving over time. So for example, here you can see this chart as timeline goes from the top to the bottom, and at the very beginning we have the empty state. Yeah, this is the pipeline state. And when we executed one task in the pipeline state, we will have the key that represents the specific task. Yeah, it will be the task name, and we have the result, what was returned from it. And like as we executing more and more tasks, this pipeline state will grow, and there will be new keys with new results. And if you use an iteration, every result from every iteration will be added to the sequence, and the whole sequence will be stored as a task result for that specific task. And all this state, yeah, it doesn't make sense to keep everything in memory, yeah, because you might execute a task, but then you need to execute 20 more tasks, and you don't need to keep the state in the process runtime on the heap while like this another task executing. So all state is stored under the hood as Apache arrow format, and it offloaded from the heap to the file system, and yeah, kind of using all the features from TechML library here. So in TechML library, you can store the file in Apache arrow format, and then you can use that file, not loading it into heap, but just memory mapping the real file from the file system as you would have it into your memory. So actually all data is like off heap and just memory mapped, thankfully to TechML library, so it won't blow up your GVM process. And yeah, one like tip or note here is that TechML and Apache Arrow, they kind of optimize it for collections. And collections means you can think of them as vector of maps, right? So if you have large vector of strings, it cannot be stored as a like data set or Apache Arrow format. You need something like map to be as item inside the vector. In this case, yeah, it would work, and it will be optimized for the storage and process. And right now, you cannot store nested data structures as an Apache Arrow format. This is the limitation of TechML library, but I think yeah, maybe we will overcome this limitation. Right now, you can just use simple types in your items inside the collection, like strings, numbers, dates, UUIDs, and you can use lists of simple types. So you cannot have many nesting level of maps, for example. Yeah, and this is if you aren't familiar with the Apache Arrow format, this is very like interesting like piece of software. For example, like DynamoDB and modern warehouses heavily using Arrow because Apache Arrow is a columnar format, so it stores your data as a columns, and it's more efficient to process and execute analytical queries on top of such format, where you don't have rows stored together, but you have your data structured as a columns. And yeah, that's why it has such brief integration with TechML datasets, because in TechML dataset, you also have columns and all your data stored as columns. So quite transparent how to map Arrow to TechML dataset. Yeah, and here is an example of how it works. For example, on the left side, we have file system where we have files in Apache Arrow format, and on the right side, we have a heap, regular memory of your process. So when you're starting some task, it gets some data from outside the world, and you can store. It will store it under the hood. You don't need to do any special things. It will store it as Apache Arrow format on the file system. But when another task requires that data as input, this Apache Arrow file will be memory mapped, and there will be a small overhead in the heap to bring some indexes, but yeah, not the actual data itself. So there will be some data structure representing the indexes and the offsets,
in that file, and this will be added to the memory. And then, when tasks executed, it will be cleaned up, so you don't have to keep it all the time in the memory. Okay, and here just a list of things that supported right now in this actions package. So there is like HTTP actions for request, for downloading data, and OAuth 2 to handle the authentication part of the HTTP. There is JDBC action. You can query relational databases. You just need to add like the specific driver for your database, for Postgres or MySQL, and then you can use that query to fetch your data. There is actions for S3, for local file system, and there is OData request that is designed to work with OData protocol to get some data from SOAP. I think the underlying thing is a SOAP. And there is another action for chronicle queues. So you can kind of integrate your batch processing job with streaming jobs that reside like outside of the Collet. But if you need some kind of integration, you can use chronicle queues to integrate these two things together. And there's a JSLT action for use cases when you get very, very large JSON object from HTTP or from databases, and you don't want to parse them, upload into a heap for processing. You can use JSLT, which works on the raw JSON, and you can select some values and you can apply some transformations just on JSON without parsing and transforming into Clojure data structures. Okay, so we kind of almost here, almost done. As I said, like we have 4 packages. We covered core actions and CLI package, and there is a special package for Docker. You can run the Docker container with similar command, and there is a like actually there is one required argument for Docker command. You need to provide environment variable pipeline spec, which will refer to the pipeline specification even file. Again, it could be local file system file. It could be S3 file, and it could be just raw even data structure. And like below, I listed all possible configuration values for Docker container. For example, you can expose JMX port, and you can connect Prometheus or whatever tool that works with JMX. Even you can collect metrics. You can collect logs. You can see here like console publisher, file publisher, Elasticsearch publisher. By the way, in the Colette, we are using new log, by the way. So thank you, Bruno, for your hard work. It's awesome library, and I very like it. And I think I have some time to show you how it works with Docker. For example, this big pipeline that calculates all metrics and fetches data from GitHub, we can run with this command. So we mount the volume to the Docker container with this file, and then we reference this file in the environment variable. And there are some publishers to get logs and metrics, and this is the main container from Docker Hub. So we can run it. And here I have in the separate tab, I have Docker Compose running with different tools. For example, I have Grafana here. So we can see in real time how this pipeline is executing. Yeah, it started executing right here. So we can see like the memory consumption.
Anyway, yeah, so out of the box, when you're running Colette pipeline, you have metrics in the Grafana, you have logs collected in the Elasticsearch, or it could be like different location. And I have Jagger, so this thing collects traces from the Colette, so you can see like what actions was executed, tasks. So it shows you like the full stack trace with timing for different actions. So you can see, yeah, that's how much actions was performed here. Yeah, and overall, yeah, it took 41 seconds to run the whole pipeline to get all repositories and all PRs with like pagination, with all HTTP requests. So these tools like built in in the Colette Docker container. Yeah, and pipeline completed, and we can see here in the reports. Yeah, I specified this folder to generate CSV with collected results, so we can see all the numbers, and we can use Vega to visualize them and represent as charts. So yeah, everything here like was calculated and stored as just plain CSV file. Okay, that was about Docker. And yeah, lastly, I want to mention that Colette is still under the active development phase. And what we going to do next with it, we're going to extend the Apache Arrow support. So if you remember, I said that there is like nested data structures not supported. So we are going to support that. So you don't have to worry about like the shape of your collections. You can just throw everything to Colette and it will figure out how to deal with it efficiently. And yeah, I'm thinking about like adding special action to, as we already store state as Apache Arrow, and there's a great tools like DuckDB or Data Fusion frameworks that can operate on Apache Arrow, yeah, without even bringing it into the memory, and you can deal with data just with that tool. So there will be special actions that integrate DuckDB, so you can query your state from directly from Apache Arrow files and perform some aggregations on it. And yeah, there is a plan to extend the actions library with crawlers, document parsers like PDF, XSLS, Excel spreadsheets, files, whatever, to include actions for machine learning models. So imagine you defined your pipeline, you get some data, and you just point Colette with some Hugging Face machine library model that can perform some regression or prediction on top of your local data. So it could be quite useful. And yeah, I already mentioned that there are some plans to include Vega with visualizations and representing the results as a result of Colette. I'm not a big fan of Python, to be honest, but I think we can benefit still if we will add support for custom actions defined not only in Clojure but in Python. So we can cover like the Python tools. They have also have like great libraries, so we can bring them up. And yeah, there is like was few experiments to create fine-tuned large language model as a Colette assistant. So imagine you can just tell Colette what you want, and it will generate the whole pipeline spec for you. So yeah, I think it's more than easy nowadays than it was before. So maybe in future we can provide this interface, and you can just describe your problem, and it will give you just the pipeline specification file that you can immediately run on your machine. And of course, there is some work in the queue to build some UI to manage pipelines, to build pipelines in the more like user-friendly UI. And yeah, there is a plan to add some scheduler and maybe API service to run multiple pipelines from the single like point, like control tower. Yeah. And yeah, that's pretty much it.